Hey everybody, let's fix the wiring on this thing, or at least analyze it and know where we're going to go next. The Tsugami's got a number of motors. There's actually 4 motors on this machine. 3 of them are induction motors, 3-phase, pretty easy to handle. This is the odd duck. This is the DC motor. We'll come back and talk about it last. So this panel has definitely been modified. These are to cap holes and seal them off, but there used to be probably a switch and a light in each one of those. One for the grinder, pressure well pump, hydraulic pump, one for the coolant pump. Over here they had the work spindle. And when you open it up, you can tell this is a new conduit here. And these are a bunch of new wires coming back into the main power control board. Fuse power coming in. And then it's all headed somewhere else to get managed by switches elsewhere in the machine. So the original wiring diagram and switching for the machine has been changed by someone. So this is the wiring, secondary wiring someone else had done, and one of the things we noticed is the contactors are the wrong size for the motors. It's an amperage setting. Also, I'm not sure if this wire size is correct, but if you don't have uglies, you ought to get uglies. It's super helpful for this stuff, and if you're not an electrician, you should go get one, because this is there's 3-phase power in this box, and it's a safety issue if you're not familiar with it. So be careful. But this is super helpful. You can do a lot of planning and talk to your electrician and figure a lot out with some of the very simple guides that are in uglies. Most electricians I know carry these. It's kind of like always in their toolbox. Here's the conduit that comes from the other side. These are the wires we saw from the other side. So we can see these dark blue wires are 223-phase coming in. And this comes to all the switches and contactors, switches out here on the outside of the box. So this is how they've replaced everything. Now this conduit right here also is new, and it comes to this box, which is called an SCR box, silicone rectifier, silicone controlled rectifier. Now this box talks to this direct current motor. It's different from the other one. It's not a 3-phase induction. This direct current shunt motor needs a specific driver, so you need an SCR. Normally you'd see a box like this, you might quickly think that it's a variable frequency drive, but this is a driver for this DC motor. It's an SCR box. All right, real simple. So when you're looking at this equipment and you want to size it up, see if you want to reuse it or see if the specs are right, you need to look at all the markings on it. So Baldor has really good documents. They keep track of this stuff really well and have a lot of resources in that regard. So here's our BC154. That's what it is. So again, to further check these things, a lot of these resources are on the internet, and you can come back in here and provide these specifics to your electrician or for yourself if you are one, to make sure you get it right. Again, most of these are amperage and cable size ratings, and then phase ratings. This is going to take single phase 220 and convert it to direct current for this motor right here. And this knob will vary the direct current for that motor, so you'll have control over the spindle. So this is your spindle. It's going to be spinning your part in this machine. Okay, on the overload relays, there's a little flyer that comes with them. They have many sizes, but the key thing here is these settings. I see these set wrong sometimes. We want this to trip and stop and have us think about it and have to reset it. So there's actually 4 settings on the overload relays. There's hand, reset, and then there's the auto settings. We don't want to use these. We don't want the machine to restart if we've got a problem with a part or a tool or whatever. So these might be okay for testing when you're first setting the machine up if you're working on it, but you really want to leave it in and one of these two settings. So this one requires a reset manually, and this has it so that you can actually test it. So either one of these would be good. So here we are. Time for the rubber to meet the road. Let's take the wiring out. But first of all, go to Uglies. If you're not an electrician, hire a good one, but you can buy this cheap and it's a great piece of information. We looked at all these wires earlier, and these are 16 gauge wires. They're too small for the duty. They need to be 12 gauge. These are 12 gauge power cables, but they all need to be 12 gauge. So we're going to take all these out. We're going to take all the conduit out that goes to the other box. And also, when you go through Uglies and look at their recommendations, it all has to do with full load amps, and then contactor and overload breakers, what their ratings are. It's a 3-horse, a 2-horse, and a 1/2 horse motor, and full load current is almost 10, almost 7, and 2. The relays that were in here in the machine as delivered to us were 4 and 4. So both of these, the previous guy complained that it would break all the time. No wonder. The breakers are way too small. So we've already ordered new breakers for these to fix it, and we'll catch up with those details next time. But let's get this stuff out of here. It should be pretty simple. It's got some little captured nuts on here. Now here's the power coming in from outside. Goes through this set of fuses, and then in the let's see. No, this is incoming, and then the power comes behind this panel and splits and comes out to each one of the motors. So there's hydraulic, grinder, and then they had a different type of setup here up front for the workpiece spindle. So we're just going to unscrew these and take them apart. I've already loosened them. Should be pretty quick business here to get the rest of these out. And again, this is an old machine. Different style connectors, but they're very well made, and we'll have no problem getting the rest of this to come apart. Pretty standard stuff. Looks like they're not big enough for the bolt they're going over. There we go. So now pull these out, and since they're coming out anyway, I'm just going to use the dikes and clear the way. And obviously the machine's off, not plugged in, lockout, tag out, all safe. So this runs up to a motor, this runs up to the workpiece spindle, so we'll leave that intact. We'll come back and confirm all these when we put the new wires in. All right, there's no doubt that this is a project, but since I've done a few, it's kind of fun to show it. All the good, the bad, and the ugly. And it's too bad they drilled the machine to put all these in, but we may or may not use that same path. We may just use the original design intent and rewire the machine that way. Now this is a mess in here. These are the overloads that are all the wrong size, and contactors. Get a good pair of dikes, take care of them, they'll take care of you. These are Crowders. These are older, but they're pretty handy. So again, I could mess around and unscrew these, but the wire's too small. It's coming out. Just a few. And there's a nut in there. There we go. Done with that. So we may salvage some of these switches, I'm not sure, but let's take it the rest of the way off the machine. And there's nothing like taking it all the way apart to see if there's any other signs of struggle or damage or electrical issues. So when in doubt, take it apart. All right, that's it. Now, here's a few issues here we're going to clean up. We need some sort of better mounting mechanism for this. This is not the original coolant pump, but it works great. It's new, it's a gray bar, gray mills, but it doesn't fit down here on this bracket very well. So we need to fix that. This is the original 10 for the original one, but it's not fitting too gracefully. So we'll maybe make a little spacer here to organize that. We just took this box off, and here's our DC shunt motor and then the SCR drive. That SCR drive needs to be mounted back here somewhere out of the way. The whole slides. This whole ways for the machine goes back and forth. So it needs to be out of the way so that the electronics can come to this and flex. So we'll need to get that cleaned up a little bit. I think some of these cables are a little short. It was mounted on the front and moved back and forth with it, but I really don't want that. I want the SCR drive to be steady and just one single wire that has to flex over here. We'll choose wire that's for CNC machines that's built to flex a lot, so we'll get a piece of that to make sure we use it where necessary here. All right, now over here, this is the original breaker box for the machine, and somebody's put these protective caps here. I'm going to open these back up. We're going to take this off here. There's not a lot of room behind it, but there might be enough if we take some of this out and redo it. But it's possible that we could put all our contactors and relays back in here, and then our switches back in these handles with indicators, and put the machine back together the way it was originally wired. Save a lot of space, not have a bump over there, and it's even labeled nicely. So we'll see if we can put that back together. This cabinet is the one where this handle was that I had to cut off. So, and then I harvested out the field generator, which actually still worked, but we're not going to use it, unfortunately, because the exciter down in the base isn't working. But in this particular deal, I want to talk to you about these. I did a little screencast on them showing these, but you want to make sure these are set in hand. There's 4 settings. And a little screwdriver will do you to make the setting. So there's the automatic settings, and you push it in so you can make the adjustment if you want to go automatic like that. That'll just keep resetting it, which is not good. You don't want that. You don't want auto. Maybe when you're setting the machine up and you're testing some things under very controlled situations, when you're operating, normal operating condition, it needs to be in one of the hand settings. So if the little red dial is depressed, and it's pointed down to the right on one of the hand settings, that's where you want it to be. All right, so down and to the right are the 2 hand settings. The upper ones are the auto settings, so make sure you get those right. But all of those contactors are put back in a stainless steel box. It was inside this big casting, but I needed to mount the DIN rail. I wanted to get it in something that would keep it a little cleaner, and so this is we made this little stainless steel box. I think I showed some pictures of it. So that seals up this side of the machine and puts all the relays with the correct settings for their motor amps. Oh yeah, the amp settings, also small screwdriver, are right here. And it might be hard to see, but there's a little dot. There's a little dot on this dial, and that's where you put your full load amp setting. and that's where this thing will trip. Counterclockwise, two little gears touching each other, and this one's set right in the middle, right there. So full load amps, 1, 2, and 3, and all on hand. That's the way you want to ride. Okay, the SCR box or DC drive for the workpiece motor. The electrical box that somebody else mounted, I decided to leave it here, and then I'm just going to use it as basically a bracket. This brings this box down low. It's right here, super easy to operate it and not have this knob moving around when you're operating the machinery. Now, we hooked it all back up to here. Got a really nice gland nut put in the motor. Used MTW, machine tool wire that's flexible, and wired back into this box here and wired back into the machine. And this circuit's good to go, and this gearbox is good to go, and it works great. So that was our solution on this end, and that's good for now. In addition, just as kind of an added thing, this box will also let us hold like our high pressure grease for our centers and some of the tooling for machine specific tooling. It's got a lid on it too, you can put it on so you can keep all your stuff together. That's that. Piece of cake.